Desmond mows lawns in his neighborhood for summer employment. Unfortunately, right at the peak of lawn mowing season, his lawnmower breaks down. Desmond is faced with an important decision that he needs to make in a timely manner. Should he pay someone to repair the current lawnmower, or does he need to buy a new mower? What factors are important for Desmond to consider as he thinks through his decision? Slide 2. Option 1, repairing his current gas-powered motor. The cost of the repair will be $160, after which the cost to operate the repaired mower is estimated to be $45 per week. Option 2, buying a new energy-efficient electric-powered motor. The cost of a new mower will be $400, after which the cost to operate the new mower is estimated to be $15 per week. So now let's create equations to model the options. Each equation should model the cost of the option, y in dollars, as the function of time, x in weeks. So option 1 is y equals 45x plus 160. Option 2, y equals 15x plus 400. Slide 3. Desmond's best option will be the option with the smallest total cost over the rest of the mowing season. A. Which option is best if there is little time left in the mowing season? Option 1, because it is a smaller initial cost. Part B. Which option is probably best if the mowing season has just begun? Option 2, because it has a smaller operational cost per week. Part C. What is the system of equations for options 1 and options 2? Y equals 45x plus 160, and y equals 15x plus 400. Slide 4. Graph both equations and find the point of intersection. What point is the solution of the system? So the two lines cross or intersect at 8, 520. Slide 5. What point is the solution of the systems? Again, it is 8, 520. 7. What does your solution represent? At the end of week 8, both equations have a total of $520. Number 8. What is the best option depending on the different scenarios? If there are more than 8 weeks left in the mowing season, you should buy a new mower. B. If there are fewer than 8 weeks left, repairing the old mower will be less costly. Skip slide 6 and go to slide 7. The two options, option 1, $10 per week plus 0.125 cents per click. Option 2, $6.25 per week plus 0.2 per click. X represents the number of clicks, and Y represents the total cost. So now write the two equations. Y equals 10 plus 0.125x. Y equals 6.25 plus 0.2x. Move on to slide 7. So we're still here. Graph the two equations and find the point of intersection. The solution is 50, 16.25. At 50 clicks, the total cost is the same for both options. At that point, the total cost for option is $16.25. Therefore, the first option becomes less expensive than the second option after 50 clicks for the first week. And move on to slide 8. Write the system of equations for table for first payment. So looking at the table for payment A, the slope is $0.15 per 5 clicks, which equals 0.3 per click. And the y-intercept is the number 4.5, which gives us the function rule, y equals 0.3x plus 4.5. Let's keep looking at the table for the second option plan. This time the slope is right here. 1.25 divided by 5 clicks, which equals 0.25 per click. The y-intercept is 8. So the function rule is y equals 0.25x plus 8. So now use the calculator and graph the two equations to find the point of intersection. So as we see down here, the point of intersection is right here, which is the point 70 and 25.5. So after 70 clicks in 1 week, the total cost of each newspaper A's payment plan will be $25.50. Staying on slide 8, let's look at the graph. So the slope for the first one is 10 cents per click, and the y-intercept is 15. So that function rule is y equals 0.1x plus 15. For the second payment plan, we have a slope of 50 cents per click and a y-intercept of 5. So my function rule is y equals 0.5x plus 5. So now use the graph to answer the following questions. What is the solution of the graph? The solution is right here at 25, 17.5. So after 25 clicks in 1 week, the total cost for each of newspaper B's payment plans will be $17.50.